In this video, we'll be differentiating, but we'll be including, as the title suggests, trigonometric functions, but also exponential and logarithmic functions. There are separate videos for parametric and implicit differentiation. To begin with, on the left-hand side, we're going to look at an example of the chain rule. So cosine 2 of x is the same as cosine bracket 2 of x. So there's the inside part of 2 of x. We differentiate the outside function and we have this inner function as well. So the derivative of cosine is minus sine. So we have minus sine times 2x and then times the derivative of 2x, the inside part, which is in fact 2. And then you can just put the constant of 2, of course, out the front to make it easier to do further expansions on these questions. Ideally, you should have a list of the derivatives in front of you on paper, so you can check them as you go along with these kinds of questions. Our first question here, we're going to denote the inside part as u, and u is x squared minus 3x plus 7 for our first term there with cosine. Just rewrite that, yep. And again, we're going to do the derivative now of dy over du. Of course, the derivative of cosine is minus sine, so we've minus sine u. So du over dx is 2x minus 3 is the derivative of u, as you can see above that. So plugging this in now, we can plug in u and put it all together. And follow up with our du over dx. And that's pretty much it sorted. We can bring some parts to the front. You want to kind of organize it in a way that if you had follow-up questions, to expand it or to deal with it, to make it as easy as possible to read. But that looks okay. So second part here, we've got sine and e to the x. And I'm doing the same thing again. So the derivative of sine is indeed cosine, and a special case with the exponential function that is its own derivative. So we have cosine u, which again is cosine e to the x, and again also to e to the x. That's what the chain rule is what we're doing here. Just have a look over it in its isolation if you need to. So put all this together now, our minus sine, we're going to put our 2x minus 3 out front. And then put it all together. And everything else is pretty much the same, but I'm going to put the exponential function out the front as well. Okay, and that's the first part A done. So we've done one of our, we call it trigonometric functions. The next one is actually a natural logarithm, just to show another idea in these kinds of questions. Same kind of thing. So we're replacing the ln x or 2x cubed with u. The derivative of the natural logarithm is of course 1 over x, in this case 1 over u. And we've also got the derivative of the inside part, 6x squared. So again 1 over u, which is 2x cubed times 6x squared. And simplify that. You'll get 3 over x. And there's actually another way of doing this. I'll just put it down the bottom. If you don't actually have to use the derivative, ln 2x cubed is 2 parts. So ln 2 plus ln x cubed. And again, bring your cubed down, you get 3 ln x. And that's the same idea, 3 over x, when you do it out. In this question, we have a function of x equals sec or secant 7y, which is a little bit different to your usual convention. So you're probably used to looking at dy over dx, so we're going to have to do a little bit of manipulation here. So we're going to have to find dy over dx in terms of y, and in the second part in terms of x. So there are going to be maybe product rule, quotient rule. I have them there. There's other aspects here. You might need to know also, like secant or sec is also 1 over cosine. So 1 over cosine 7y is equal to x. So from here we're going to just find dx over dy. And we can reverted back at the end. We're using the quotient rule. Which at this stage you need to just look over yourself in isolation, but it is there on the right hand side. So again, the bottom part, cosine 7y, square all that. Simplify it down. The first part disappears, so it's plus minus minus is a plus. 7 sine 7y over cosine 7y squared. Here now we have an interesting part where you think to yourself, it's sine over cosine, that's tan, isn't it? So that's one of our identities. It could be something else. Just have a quick look at it. So it gets rid of that. So we still have a 1 over cosine, which is actually the secant as well. So we have 7 tan 7y and sec 7y. And that's worked out fairly nicely there in terms of y. And of course, we have to rearrange it with 1 over because we already did dx over dy. So this new answer you see now is dy over dx, which is what is being asked for. Okay, part B, something similar, but we're going to use one of the identities here. So sec squared is equal to tan squared minus 1. So sec 7y equals tan squared 7y minus 1. So sec squared is x squared. So we put that bit in. So x squared, just to replace x in there, is equal to the tan squared 7y minus 1. Move them over, so x squared minus 1, so plus 1. Cancel 1 about minus 1 on both sides. So tan squared 7y. Again, your square becomes a square root, or cancel both sides with the square. So x squared plus 1. And again, we've got 7y. So dy over dx is equal to 1 over 7x, and then root times root x squared plus 1. So be careful with that bit there and cancelling both sides with a few things. And 7x, of course, comes from 7y. I'm doing it in terms of x. So instead of 7y, we have 7x times that. And that's another one of those kinds of questions. dy over dx.